So we should start now. So are you able to see this question? Hello.
Yes, sir.
Okay. So we have been given in this question that a transformer, single phase transformer with 440 volt, 60 hertz operating frequency has 660 watts of hysteresis loss and 220 watts of eddy current loss under rated conditions. The estimated constant is 1.6. Estimate the hysteresis loss if the transformer is operated at 310 volt 50 hertz. So we'll start solving this question. Initially they have given that P, you very well know that hysteresis loss is equals to some K, some constant into F to B to the power of estimate constant, that is taken to be 1.6. Next, your eddy current loss is K, sorry, take this as KH is in KE F square B square, and it is also a function of thickness T square, but since this is constant we are not considering that. Also, flux is proportional to B, and this is proportional to V by F. In the last session I told you that flux in a machine is proportional to V by F. So if we replace pH, sorry, pH as KH F into V by F to the power 1.6 and P eddy as Ke F square V by F whole square. So we will find that hysteresis loss is in initial first case 1, when the operating voltage and frequency are specified, that is when if a frequency is 60 hertz, operating voltage is 440 volts. So they have mentioned that hysteresis loss is under these hysteresis loss is 660 watt and eddy current loss is 220 watt. So substitute here, you will get 660 watt. 660 is equal to kh, f is given as 60, v by f, sorry, v is 440 volt upon 60 to the power of 1.6. Okay, now from where, from here you can get value of kh, the proportionality constant. So One way is this. Other way is, let this PE P sorry PH at PH is equals to KH into operating frequency is 50 hertz now, voltage is 310 upon 50 to the power of 1.6. So if we, these are two equations, if we compare them to find, or we solve them by taking the ratio, or then you will get PH somewhere as something 420 watt. Please solve and let me know the exact answer. Are you guys getting?
Yes, sir. But what exactly we have to calculate, sir?
We have to calculate pH now.
Sir, you have already given the answer.
Uh-huh. So I want to cross verify, are you guys getting the same or not?
Okay, sir. Yes, sir. We also have the same answer.
Almost this must be near to this value.
Yes, sir. 420.4429.
Okay. Now they've asked eddy current loss at under these operating conditions. So same with this, for this equation we can write PAD is KE, since F is in denominator and bearing power 2, so we can cancel out F square into V square by F square. So we can say that eddy current loss is directly proportional to V square now, independent of the operating frequency. So PE is given as 220 watt. 220 watt is proportional to operating voltage is 440 volt square upon P is 310 square. Please solve and let me know what is eddy current loss. Is it coming out to be something 109.20 watts?
Yes, sir.
Okay. So we will move now to the next part.
Okay, sir.
Are you able to see this question? So
Yes, sir.
they have given that an equivalent circuit of a transformer with following uh, ratings has got an equivalent circuit referred to a low voltage side, referred to low voltage side with parameter values as R naught is equal to 150 ohm, magnetizing branch inductance is 80 ohms, effective resistance referred to low voltage side is 0.08 and XE is given as 0.22 ohms. Now they have given that the LV side is energized with the rated supply. That means rated supply, that is 200, they are energizing the low voltage side with 200 volts, and a load of 90 plus RL load is connected at on the high voltage side. So they have asked to estimate low voltage current. What is the current being supplied? By supply means they are asking. So they have already given the parameter values, and this is simple a network theory question with given values of RL. One thing you need to keep in mind, when this load is given as it is connected on the high voltage side, so when you will refer it to the low voltage side, you need to divide it by the turns ratio in order to get the load reflected towards the low voltage side. What will you do? This is 200 volts. They have asked this current IS, I mean to say I sub IP, they have primary current drawn, they have asked. Value of XM is given as J80 and this is given as 150 ohms. Now effective resistance is 0.08 and leakage inductance is XC is equals to 0.22 ohms. Now if you will transfer the load to the low voltage side, it will be, what turns ratio is, turns ratio is
1/10.
okay, 1 by 10. So this load will be reduced to 10 square. So what will be the value of load now in the low voltage circuitry, low voltage circuit? That will be 1.9 plus J 1.1 ohms. So this is considered as IS dash and this is I no load. So you have to ask, it has been asked to find out the current in the low voltage side. So that is IP, this will be equal to I naught plus IS. So proceed to solve this question. What you have to do, this part of the circuit is, this part of the circuit you find IS and this is connected in parallel to the supply, so you can find out directly I naught. So we will start with I naught. I naught will be equal to 200 by J80 plus 200 by 150. So what do you get? I naught Please solve and tell.
Sir,
Yes.
how to come out on turns ratio, sir? It's the formula of N1 by N2
Yes.
or
See, don't N1 by N2 or nothing like, since they have specified the high voltage,
voltage, sir.
they have specified this is high voltage side, so this is 200, sorry, and this is low voltage side. So once it is specified, so in the question itself they have given it is 200 oblique 2000 volt. That means an NLV to NHV is 10, 1 by 10. Okay, so whenever you will since this load is connected on the high voltage side, when you will put this reflect this load into low voltage circuitry, we need to divide by 10 square, and and other these values, equivalent transform series resistance and leakage inductance have been already given, that they have been mentioned after being referred to low voltage side. So just you need to refer this load by dividing it by 10 square. Clear?
Okay, sir. Thank you.
Yes. So I naught, please calculate I naught. Is dash will be 200.
So I naught is equal to 1.33 minus 2.5 I
Okay,
J
1.33.
minus 2.5 J.
Please tell in form of polar, instead of telling in rectangular coordinate. Okay, we'll do it later on.
Two-
We'll convert later on.
2.83 angle minus 62 degree.
2.83.
83.
Okay, 2 point.
83
Yes, 3 angle
angle minus 62. Minus 62.
62. What about I? Similarly, is will be 200 angle 0 upon 1.98, adding these both resistance, this value and this value, plus J 1.33, sorry, 1.32. All of you are bearing your calculators or not? Please solve and tell the answer. So total,
Yes, sir, we have the same answer.
okay. So
Sorry, sir.
total current IP is summation of I naught plus I station. So add both these, you will get primary total current drawn by the low voltage side. What are you getting? This is 2.83 angle minus 62 plus 84.045
Sir, please tell me, sir, how to come that's 24.0445
24
and
point.
what is the process?
Please repeat your question.
How to come, sir? What are the process here? To division process of how to solve that
Okay, see, if
rectangular
you are
or
having, if you are having scientific calculator, if you are having
yes, sir.
if you are having scientific calculator, you may
Yes,
above 100 ms by Casio, you can directly choose the complex mode in that calculator and
okay.
compare you can do. Otherwise, if you are not having knowledge how to do using calculator, you can simply rationalize this and do it. This can be rationalized as is dash is equals to 200 angle 0 into 1.98 minus j 1.32 upon 1.98 plus j 1.32 into 1.98 minus j 1.32 a plus ib, and this is a minus ib, so this will become
A square
200
minus
1.98 as j 1.32 upon 1.98 whole square plus 1.32 whole square. So now you can convert it
sir,
after
A
this.
plus B into A minus B, A square plus A square minus B square, sir.
No, this is j na. So
Okay,
you
okay, sir.
minus of j square will be equal to j, since j square is equals to minus 1, so minus of j square will be plus 1.
Okay, sir. Okay, sir. Clear, sir. Thank you.
So all are getting this primary current as 86.55 angle minus 34.57. Yes or no?
Sorry, 86.3228.
Yes. This is just due to some errors. Acceptable answer should be within 86 point something, no problem. So we will move to the next part now. They have asked estimate the low voltage side power factor. So it is simple. Since you got that primary current which is drawn from the low voltage side is equals to 86.55 at an angle of minus 34.57. So simply power factor will be PF of low voltage side will be cos of 34.57, that is approximately 0.82 lag. Clear?
Yes, sir.
Okay. Now next part of this question is find the terminal voltage at the high voltage side. When this we are operating under the mentioned conditions, they have asked what will be the voltage across the load. Okay, so we have got that referred current is dash is 84.045 at an angle of 33.69. So So IS dash referred secondary referred low voltage current is 84.045 at an angle minus 33.69. 33.69. So this is in the low voltage side, this is a reflected current. So what will be the original current in the high voltage side? That will be multiplied by 10 times, sorry, divided by 10 times. So IS in high voltage side secondary current, this will be IS dash by 10, that is equals to 8.4045 at an angle of minus 33.69. Rounding it off, we can write it 8.405 angle minus 33.69 ampere. Now your load is given as ZL, they have given as 190 plus J, 190 plus J 110 ohms. So what will be the value of voltage V at the terminal voltage? Voltage V high voltage side is equals to IS HV into ZL. So multiply 8.405. You can find this as 190 plus 110 shift I, that is 219.54 angle 30.06. So minus 33.69 into 2 1 sorry angle 30.06, 219.54 angle 30.06. So multiply this and tell me what is the answer. So magnitude they have asked, VHV is equals to 1845 approximately. Are you getting the same? Are you getting the same?
Yes, sir. 1845.23.
Yes, yes. Approximately this is 1845.
Okay, sir.
Okay. Now they have asked estimate the next part is estimate the output power in watts. That means they are asking the real power. So many approaches are there to solve this. See, this is V voltage you are having, I current you are having. So real power real power of load P will be real part of apparent power. And what is apparent power? Apparent power will be real part of V into I conjugate. I you are having this and V you are having this, multiply, and the real part of this complex power will give you the real power consumed. Other way is they have given that the load is RL and this is 190 ohms, and you are knowing what is the actual current flowing, you are knowing the amplitude of the current. So one way is you multiply IL square RL, PL is equals to IL square RL. So IL square will be 8.405 square into 190, that you will get close to 13420 watt. Half of you try to attempt using this part and rest verify through the second part which I have given. Both way answers should match. So let me show through this method also. I said PL is real part of VI conjugate. So V is given as 1845.27 at an angle of minus 3.62 into I is given as 8.405 at an angle of 33.69. Since it is conjugate, so angle will become plus. Now multiply these 1845.27.
Sir,
Yes.
from where was that I taken?
Yes.
From where was this I taken? I
Your voice is not clearly audible to me. Please speak clearly.
from where was this I taken?
Why? What I have
Please,
taken?
current I.
Acha, current, this I from where I have taken?
Oh, yes.
Just now we calculated that the current for the high voltage side is this. So
Okay,
to
okay.
calculate the load power, we will use this current only because this is flowing in the high voltage side and load is connected at the high voltage side. Clear?
Okay, okay.
Answer 15509.49, sir.
Yes.
And
Angle 30.07. So find out, this will be real part will be 15509.24 cos of 30.07. That is coming approximately 13422. So we are getting the answers both as same, approximately same. This is just due to the decimal approximation and the rounding off. Okay, so both way we are getting the same answer. Now they have asked to estimate the efficiency. Okay, efficiency. efficiency will be, what is formula for efficiency? That is output power divided by the input power into 100. So output power is approximately 13422 upon, we need to calculate input power. So what we will do similarly, we know that input side is 200 volt and current at the input side is, total current is 86.55 angle 34.57. So what we will do, 86.55, we need to first calculate the input power. Input power will be this will be V, sorry, V I conjugate. I is this conjugate, taking, after taking conjugate, this will become plus. So find out what is the input power. 200 into 0.55, this is coming out to be 14253.63 watts. So therefore efficiency, which is denoted by neta, is given by 13422 upon 14253 points something, approximately you can take 6 into 100. Tell me what is the efficiency? Approximately 94.15%. Are you all getting the same or not?
Yes, sir.
Yes, sir. 94.16%.
Okay, fine. So we'll move to the next question. Are you able to see the question? A 500 volt by 125 volt 50 hertz transformer has 400 primary turns. This is the high voltage side. It takes 6.5 ampere at 0.45 lagging power factor when energized on high voltage side with no load. They are saying that the transformer is operating under no load condition and the no load current being drawn is 6.5 ampere at a 0.45 lag PF. So they have asked to estimate the maximum flux. So through the EMF equation, fundamental EMF equation of transformer, we have E is equals to
There is someone
4.44
behind you.
F. Yes, please.
There is someone behind you.
Yeah, please ignore that. So 4.44 F 5 NPH. Okay. So they have mentioned that this is 500 Input is energized with 500 volts. Operating frequency is 50 hertz. Number of turns is 400. So they've asked rated maximum flux. Rated maximum flux means this will appear when we are energizing the transformer under rated conditions. That means we are applying 500 volt at the primary side, 4.44 into operating frequency is 50, flux we have to find, and number of turns is given in 400. Please solve this simple question and let me know what is value of flux. Quick.
5.63 into
Milliliter.
10 power 3, sir.
Yes, yes. Okay, fine. Next part they have asked estimate the magnetizing component of the rated no load current. So the no load current, you know from the open circuit test that the no load current will contribute to the uh, for this hysteresis and eddy current loss, as well as it part of it will contribute to the magnetization of the core. So let's say through phasor I will try to explain. This is flux, this is voltage. So they have given that,
Sir, what is the question?
yes,
What is the question?
question is we have to find, let me write the question first.
We
Estimate,
can't see the question.
yes, estimate the magnetizing component of the no load current. Okay, so let us, they have given that the no load current is 5.6 ampere at 0.45 lag. So the current is lagging from the voltage by, this angle will be cos inverse 0.45. Approximately 63.25. So this is I naught. They have asked if you divide this will be the magnetizing current, I will call it as I phi, and this is the core loss component, I will call as IC. So I naught is together I phi plus IC. So what we have to find? I phi, that is the magnetizing component of the no load current, I phi, that will be equal to I naught, if I naught sine 63.25. Please find out. What are you getting? There is a very small announcement from my end. Please bear your scientific calculator so that we can solve as many as number of questions in every session.
Sir, calculators are allowed
5.8
in
now.
the SIM exam, sir. Final exam.
Yes, yes.
So
Okay,
the
sir.
angle should be taken as minus because the power factor is lagging.
So see, we are measuring. See, in any system, generally voltage phasor is taken as reference. So current is 63.25. Now they have asked us the magnetizing component of the load current. So this will be, if this, if I'll ask, this will be this part on this towards V, this IC will be I naught sine of this, sorry, cos of this angle, and this will be, if I consider this as phi, so this will be I phi will be equal to I naught sine phi. Simple. Why to take negative here? It is basic coordinate geometry. Clear?
Okay, sir.
So see, when angles are defined as positive and negative when we are commenting on the power factor, if I would ask, see here in the question itself, they have given 0.45 lagging PF. Lagging PF itself means that their effective load is RL. It is somewhat inductive in nature. So current has to lag by voltage. So positive or negative will be dealt when we are going to define the power factor. Okay. Here simply it was asked about the magnetizing component of the current. Next part, are you clear? Everyone is clear with this?
Yes, sir.
Okay. We have now next part is estimate the iron loss. Estimate the rated core or iron loss. Since they have used the term rated, so that means we have to consider this primary voltage as 500 volt. Under rated condition they have asked, so rated frequency is 50 hertz. Now please find out what is the iron loss. See, it is mentioned in the question that the transformer is operating under no load. So whatever you are giving, that is going to part of that current is going to supply for maintaining the flux, and rest will contribute to the core loss. So simply you can find out Pi, that is iron loss or the core loss. Are you able to see my screen? Hello?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Okay. So simply we can find it by Vi cos phi, that will be 500. I they have given as 6.5 into cos of this angle 63.25. This will be the real power loss, and that will be contributed as core loss or iron loss. Please find out.
1462.81 watts, sir.
1 4.
62.81 watts.
Fine. This is iron loss. Any doubt in this part? So we will move on to the next
No, sir.
question.
Sir,
Yes.
I have one doubt on SWAYAM exam, sir.
Okay. Ask.
It has a theoretical exam or a multiple choice.
Uh, Actually, I am not your regular teacher, so I have been assigned to for your doubt clearance and basic uh, any in case you have, for as a help for your assignment solving, and in case you have any doubts to clarify those doubts. So all this examination will be taken care by NPTEL. You need to raise your queries there. I am not knowing how what sort of questions, and but I what I think so that there will be a uh, exam in online mode which you have to give. That will mostly consist of these numerical answer type questions, or and plus a few option type questions. Clear?
Okay, sir. Thank you.
These all are simple questions, and I think so. I have in the very first session I have solved these questions when I was not aware what type of questions they give in your assignments. So for question number 11, they have given that rated kVA is 1770, operating frequency is 50 hertz, transformer and primary turns are 400, and 100 are the secondary turns. Low voltage side voltage is 240 volt, estimated the rated primary voltage. So this is very simple basic question. What they have given this as 400, this side it is 100. They are saying that the second low voltage side, this is low voltage side, this is high voltage side, they are applying a voltage of 240. So what are you going to get at the high voltage side? Simply you need to multiply with the turns ratio, that will be
960.
960. Clear? So next part is estimate the rated primary current. Rated primary current. So IP is equals to rated kVA, they have given as 70. Rated, oh, so and the voltage will be 960. So rated primary current will be
72.92.
huh?
72.92.
72.9, sir. Amps.
Yes, yes. And this is what is the rated secondary current. Similarly,
So 291.67.
okay. sorry, what 70 into 10 power 3 upon 240, what is the answer? 200.
21.
291.6, sir.
Okay, fine. Next, they have asked estimate the rated estimate primary current in ampere when secondary side load draws 27 watt 27 kilowatt at 0.7 lagging pm. So estimate the primary current when the secondary side load draws 27 kilowatt at 0.7 lag pm. So what you have to do, they have given there is some load which is drawing 27 kilowatt at 0.7 lag pm. So what I will suggest you, since apparent power SHV will be equal to SLV, we consider, so real power you are knowing, so find out the apparent power. What will be the apparent power? SLV will be equal to 20, this is 27 divided by the power factor, that is 27 into 10 power 3 divided by 0.7. That will be 38.57 kVA. Okay. Now you have to calculate the primary current. So IP, sorry, if I ask, this is HP, this is LV, SLV, sorry, SHV will be VH high voltage into I primary conjugate. So this is 500. What is sorry, 960. Please calculate what is 400. Please calculate. What are you getting?
Or 3.17.
IP you are getting as 40.17 amps. Okay. So secondary, what will be the secondary current? Similarly, they have asked for the secondary current.
sir.
Since this is a step down transformer, so current in low voltage side will be higher, ILV, or what we call IS, will be equal to IP into turns ratio, that is 4 into 40.17. Yes, any doubt?
Sir, SHV equal to VHV into IP star, no?
Yes.
And that IP star is equal to IP, is it?
This IP is equals to
IP star, both are equal.
see, actually what I should have written, okay, I am just not
So no need of angle.
not dealing in terms of, they have asked only magnitude.
Okay,
So
okay. Angle is not needed, okay?
yes.
Okay.
Similarly, secondary current you can find out by multiplying with the turns ratio. Now, clear till here? So, we will go with the next question. Now, question is, when the high voltage side of a 500 volt by 125 volt 60 hertz step down transformer is excited with the rated voltage, it draws current of 3 ampere at 0.25 lagging PF under no load. Under a lightly loaded condition, transformer is delivering 14 ampere at 0.9 lagging power factor to a load connected to the low voltage side. Leakage reactance and winding resistance are negligible. They have asked estimate the RMS value of primary current. So they have given that leakage reactance and winding resistance are negligible, and also they have given the no load current. It draws 0 current of 3 ampere at 0.25 lagging under no load condition. Under lightly loaded condition, transformer is delivering 14 ampere at 0.9 pf lag to the load connected to the low voltage side. What you have to do? Transformer is given like this. This is high voltage side. This is low voltage side. At the low voltage side, transformer is delivering 14 ampere at 0.9 lag. So what is the angle? If I ask what is the angle, the shift, what will say shift? No, cos inverse. That is 14 angle minus, since it is lagging, so 14 angle minus 25.84 degrees. Also, they have told that no load current is 3 ampere. So what you have got, IS is 14.84 sorry, 14 at an angle 25.84.
Hello, good evening, sir.
Yes, good evening. IS is
Happy Independence Day, sir.
yes,
Happy Independence Day, sir.
happy Independence Day. Happy Independence Day to all. So IS is given as 14 ampere. I naught is 3 ampere at angle 0.25 lagging. So what will be the value of 0.25? That is 3 angle minus 75.52. So what will be the value of I primary? So IP will be equal to IS dash referred current into the high voltage side plus the no load current. So IS dash will be IS divided by number of turns ratio, that is turns ratio N is equals to 500 by 125, that is 4.
4.
That will be that is 3.5 at an angle of so I naught is this, IS dash is this, so simply add these values vectorially. IS dash is 3.5 angle minus 25.84 plus I naught is 3 angle minus 75.52 degrees. So IP is, add these values, what are you getting?
Five point nine zero at an angle 40 minus 48.64.
Very good. Are others getting the same?
Yes, sir.
Okay. Now next part is estimate the primary power factor. Nothing to do it, as in power factor will be cos of this value. So input power factor,
0.66, sir.
yes, but you need to say, it is important to say, that is cos of minus 48.64 is equals to 0.662 or 0.6627, it is coming 0.66 take. So you need to write this 0.66 lag. You cannot leave this simply, you need to comment, since angle is, this current is bearing negative sign, so you need to say it 0.66 lag. Had this current been something 1 at angle 40 degrees or something, so when you would find the power factor, you would write let's say cos 40 is 0.76, so you will mention it 0.76 lead in this case, since current is having a positive angle. Clear? So one of you were asking couple of minutes ago. So clear?
So when current is positive, you should give lead, no?
Yes.
When current is positive, we have to give lead.
Yes. So if angle is positive, uh, if if angle is positive, so then there
Okay, okay.
will be
Angle is positive, it is lead. Okay.
yes, yes. See, this is V. Let's say this is V phasor. When we have a RL load, suppose this is some voltage, AC voltage, we have some R load first. Then current is directly in phase with voltage, so we called it as unity PF, because current between angle between V and I is 0, so it is cos 0, that is 1 unity power factor. When you will replace this load by R and L, there will be the current will not no longer be in phase, this will be lagging the voltage. So this angle will be, let's say, minus 30 degree. So what you say, cos 30 degree lag. Okay, suppose now you replace the load with R and C, current will lead here. So let's say it is leading by 30 degrees, so we'll say cos 30 degree lead. These are the PF under varying cases. This is RL load, this is R load, this is RC load. Okay, clear? Yes.
Yes. Yes, sir.
Yes, sir. Yes, sir.
Okay.
Sir,
Yes.
sir, the link for this meeting is not properly working above 1 hour, sir.
Maybe
Then I will.
see, recording will be available to you, but link is same always. Maybe there is some network issue from your end.
Yes, sir. And sir, register the link for registration form to register for for the main exam in electrical machine
Yes.
is not working, sir. Then
Please ask to your regular TAs. I don't know about all these things. I am just assigned to you people to clarify your doubts and help you out, you people, in your assignments. Regarding the examination and all, you need to contact your seniors. Yeah,
then
so
what is the
yes,
email ID of TA, sir? Our TA.
I don't know. You have a discussion forum, right?
Yes, sir.
You post your queries there in the discussion forum. Okay.
Okay, thank you, sir.
Okay. Now I am going to solve another question. In the very first class, I have already discussed this type of questions related to no load test and open circuit test. Sorry, short circuit test. Huh. Consider a 125 kVA 2200 by 330 volt transformer with the following test result. Open circuit test is performed from the low voltage side, high voltage side is open. This is these are the there is 1875 watt loss, 13 ampere is the current. These are the values from the voltmeter, ammeter, and the power factor, sorry, the power meter, watt meter, which is connected to measure the open circuit power. Now short circuit test is performed at under these conditions. Okay, we are having short circuit, and that means open circuit test will give you the core loss, and this short circuit test will give you the copper loss, and these are, it is performed at 50 volt 57 ampere is the short circuit current. And so the impedances of the equivalent circuit referred to primary side are named as REHV, XEHV, this is R0 HV, and this is magnetizing branch inductance referred to high voltage side. They have asked estimate the equivalent winding resistance referred to high voltage side. Please solve. Okay, first let me see. This is, they have given winding resistance, equivalent winding resistance referred to high voltage side. That means this is obtained from winding, these series parameters RE, HV and XEHV are calculated under short circuit test. So I have already told you, this is plain an RL circuit. We need to ignore this part, we need to ignore this shunt branch during short circuit test. Short circuit test. So let me first further let me explain it more clearly. Equivalent circuit under OC, open circuit test, and this is equivalent circuit under short circuit. Under open circuit test we need to ignore the series impedance, we will need to consider the shunt branch. This is R0 HV, this is XM HV, and this is okay. So now when they have asked equivalent winding resistance referred to high voltage side, so this part they have asked. This is the current value is given as the
57 ampere, sir. Sorry.
what answer have you got?
0.38 ohm.
Okay, right. Others?
So it is the same 0.384 ohm.
What? Please repeat.
0.385 ohm.
Fine. Okay. What is RE? It's 0.385 ohms, or you may write it simply as 0.39 ohms. What about XE? What about XE?
Sir, I want see the parameters, sir, please. Just scroll down the screen, sir. Okay. Thank you, sir. Sir, 0.79.
0.78 ohms. Okay. For others, are everyone is everyone able to solve? further, suppose I am giving you the solution how to solve. What they have given, PSC is, P short circuit is given as 1250, V short circuit is given as 50 volts, and ISC is given as 157 ampere. So since this is an RL circuit, so real power loss will be 1250 is equals to ISC square into RE. So from here you can simply find 1250 divided by 57 square, 0.385 ohms. Now this is RE. What about XE?
Yes, sir. Under root Z equivalent minus resistance.
Yes, this is XE will be equivalent resistance. You can find out, that is ZE is equals to VSC by ISC. We will get 50 divided by 57, that is
0.88 ohm.
0.88 ohm. So XE will be equal to under root of ZEHV square minus RE. So we will get XE is
0.79, sir.
Okay, 0.79 ohms.
Ohm.
All others are getting this? Clear?
Sir, please go through its phasor diagram, sir. Very quickly, sir.
Phasor diagram. So
Yes.
see, this is under this condition, short circuit test. What will happen? This is RE. Suppose let's say this is the input voltage VSC. So we are considering this as reference. So VSC. This is at 50 angle 0. Now current is, this is a purely RL circuit, just now I discussed. So current will lag something here. So this current they have already given as 57 ampere. 57 ampere. Now how much this will lag? This will be given by tan inverse X by R. For a series RL circuit, this phi will be tan inverse X by R. That is,
Yes, sir. Which is also known as short circuit power factor.
yes, you can call it as short circuit power factor
A
also.
full load power factor.
Yes? No,
Full load.
no, you cannot call it as full load power factor.
Okay, sir.
Because your full load power factor is under the, when the transformer will deliver the rated kVA, then you will call it as full load power factor. Here it is not delivering the rated kVA. The aim of short circuit test is to extract the full load copper loss, not the rated power. Okay?
Yes, sir. Okay, thank you, sir.
Okay.
Sir,
This will be 63.
what about the phasor diagram, sir? Yeah.
63.73 degree. Yes. So
Yes, sir. Yes. Carry on.
this will be the angle. This will be minus 36.7 degree. Now, case of open circuit test. What we have to calculate next part, R naught and XM. Okay, so how will you do? Here they have given what are the rated conditions. Open circuit said 1875 13 ampere. POC is 1875 watt. VOC is 300
30 watt.
330 volt, and IOC is
Sir, this video, how much time is going on, sir?
yes
This class is how much time is going on?
yes it will we will conclude before 9. It is
Okay,
2
sir.
hours from 7 to 9. Now this is a parallel RL circuit, I have already told you. So how will you find out R naught?
Yes, sir.
Find out.
Eleven point zero nine.
Yes,
11.09.
11.09
09.
you are getting. This is since you know na, this test open circuit test is performed from the low voltage side, and we have been asked to find out R naught HV. So you need to refer it to high
Okay.
voltage side.
Okay, sir.
How to refer it to high voltage side? You need to multiply by the square of
A
the
square.
turns ratio, transformation ratio.
Oh, yes, sir. Yes.
Sir, I want to see the rating of the this transformer, sir, on which we are conducting a test.
But I am not getting 11.09. I am getting
Sorry,
15
sir.
point something.
I made a mistake, sir.
This is ROC is from low voltage side. So, but we want ROC HV. So we need to just multiply with What are you getting?
Sir,
Yes.
in this case, in open circuit case,
Yes.
we can may we write, sir,
Yes.
like R open circuit is equal to
Oh, yes.
open circuit power upon total current square.
No. See, why can't you write? Because the current which is going, total current which is going, that is 13 ampere, that current will go as
Exact.
RC core loss, and this will go as I phi as the magnetizing. So if you were knowing IC, then you could directly divide I square. Huh? You could
Yes,
divide,
sir.
you could write POC by I
Yes,
C
sir. Okay.
square.
Thank you, sir.
Okay. What about, is everyone getting this? ROC 2581. Similarly, XOC, how will you find out XOC? I told you that we can write na POC is equals to VOC IOC cos phi. Okay, so from here you can get cos phi. Cos phi is 1875 divided by 330 into 13, that is 0.437. So phi is equals to shift cos inverse, so that is 64.08 degrees. Now in a parallel RC circuit, there are multiple ways to solve this. I am going up following one approach. In a parallel RL circuit, now tan phi is R by X. In a series RC circuit, RL circuit, tan phi is X by R. Okay. So what will be value of X? X will be equal to R divided by tan phi. So you have got 2581 divided by 10 of 64.08. So into, what answer are you getting?
28.223, sir.
What?
28.223.
Refer to high voltage, I am asking.
Okay, sir. Sorry, sir.
No problem. There are various ways to solve this. One way, this I have solved like this. Next way to solve this question is, what you could do.
1254.36, sir.
Yes, yes, approximately same. Okay, are others getting the same?
Yes, sir.
Okay, I think so. This is all for the day today. So we will meet in the next session to discuss more.